Hi all. So today we are going to solve this Leetcode question 48, rotate image. So in the question you are given an n cross n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. So you have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not, do not allocate another 2D matrix and do the rotation. You cannot take a temporary matrix and put all the values, and you have to do it in place. So let me walk you through this image representation of the rotation, where we'll try to find out some observation and to do it in place. So the top left item for this n cross n matrix, we will have this top left at 0, 0, top right at 0, n minus 1, bottom right at n minus 1, n minus 1, and bottom left at n minus 1 and 0. So what we can do is we can first move these four elements from in place. So this will go here, this will go here, this will go to this one, and so this will go back to here. And for the next element, we will again move it like this. And so we will find out some observation from the position itself, like what we are moving and where we are moving, to find out how we can do it in place. And this one will go back to this location, right? And for the first row, we will do it till the second last row of this row, right? And for the next row, we don't want to do it from again this position. We will do it the rotation from here. So this item will move to this position. This item will move to this again like this. We will move it, and so this item will move to this location. This will move to this location, and so on, right? So to do a 90-degree clockwise rotation. So if we do some observation here, the position element at the position 0, 0 is moving to 0 and minus 1, and this element at 0 to n minus 1 is moving to uh, this n minus 1 and minus 1, right? This one is moving to the bottom right. The bottom right one is moving to the bottom left, n minus 1, 0. And so the n minus 1, 0, the bottom left is moving to the top left position. So, and the next element, if we see 0, comma 1 is moving to 1 and minus 1, right? So 0, this is 0, comma 1 position is moving to 1 and n minus 1, and this one is moving to uh, n minus 1 and minus 2, and this location n minus 1 and minus 2 is moving to n minus 2 comma 0, and n minus 2 comma 0 is moving again back to 0 comma 1 where we had started. So if we try to generalize this for a location RC, where R represents row and C represents column, so the rotation from RC is moving like this, right, to C into n minus 1. How we are deriving? Using these observations, we are deriving these new locations, right? So what we can do is, in order to perform it, is we will iterate from this position uh, till last, like half row, half length, so that we reach the middle point of it, and we will increment, start from the next corner position, do the rotation, and we will do it till and the second last element for the first row, and one less than second last element for the second row, and so on for the next rows. And yeah, we will apply this formula. We will store all these values into four different temporary variables and assign back to their new position. So let me walk you through the code. So this is the code where n is the length of the matrix, and it is n cross n, so we have one fixed length. So the rotated matrix will also have the same length, and we are starting this I. So I is the first. I is the first margin from the left. It is initially 0, and as we move forward in the row wise, we will increment this margin. from the left, and we are going till the mid row. So we are going till uh, this location only. Okay, and for each column, it will start from the left margin till the second last element, uh, and we will also decrement the margin from here. And we are assigning these four variables: top left, top right, bottom left, and assigning back to their rotated position back. Yeah, that is the in place rotation solution. Hope you like this video. See you in the next video. Thank you.